Welcome back to the $21 billion hole in Texas. This is part 2. If you haven't seen part 1, I'll pin it down below.
It's a chilly November morning in Chicago. 2 days ago, George H.W. Bush won the 1988 presidential election against Michael Dukakis. Today, November 10th, it was announced that Waxahachie, Texas would be the site for the world's largest particle accelerator. The news had leaked to the press early, and many of the physicists driving to Fermilab.
That's crazy how it ended up getting moved to Texas. I mean, any project like this, any mega project is going to be fragile, so an unexpected location development.
On that Chicago morning, had heard the bad news via their car radios. They waited and gathered throughout the halls of Fermilab and pondered the future. Would the lab be shut down? What about their jobs?
Yeah.
Later that day, around noon, they found themselves sitting in the main auditorium, where the lab's director, Leon Lederman, was going to address the disappointing news. Just a month earlier, Lederman had won a Nobel Prize for work he did in the 60s. Expecting a somber speech, the audience erupted into a fit of laughter when Lederman donned a comically large cowboy hat.
Sure.
After the noise died down, Lederman began to read his speech. Much like George Bush 2 nights earlier, he had 2 speeches prepared. One for the best case scenario, and one for the worst. Lederman began by expressing his disappointment in the site selection, and like many of those there, he maintained that Fermilab would have been a better location to build the superconducting super collider. As for Fermilab's future, he reminded the crowd that the SSC wouldn't be up and running until at least the year 2000, and that in the meantime, Fermilab's Tevatron would remain America's biggest collider. They had 10 to 15 good years left in them. Not to mention, they would likely play a key role in R&D for the SSC. But despite his assurances, the crowd was always going to be gutted. As he wrapped up his speech, he put the cowboy hat back on and left the crowd with a final message in his best Texas accent. Call me Tex.
Wow.
Texas had one big advantage.
Not to mention all the built-in infrastructure around Fermilab, both in terms of the previous accelerators and all of the big scientists that already lived there working on the project. You wouldn't have to either relocate them or lay them off.
Though, the Fermilab site in Chicago had lost out because of a local and vocal protest movement. Texans, on the other hand, were excited for the super collider. They wanted it built here.
There's a lot more space in Texas and a lot less of a not in my backyard approach. Plus, it's always been a big energy producing state anyway. So the idea of a big nuclear physics project being supported by the local population, sure.
There were Johnson Space Center. It puts the Houston in Houston, we have a problem. All of this is to say that Texas had clout when it came to projects of this scale. And a large part of that is due to Texas's presence in Washington. Take it from Joe Barton, congressman for the Ennis district where the SSC was going to be built. We've got 27 congressmen, 2 senators, and a president. If any state can do it, Texas can do it.
Unfortunately, this project's just going to be a bridge too far. I mean, again, the core technology stack, if you will, the magnets and control systems aren't fully realized. So, yeah, I'm wondering what's going to happen when they start making however many kilometers of tunnel that they get before they decide, no, no more.
You get Martin Frost on the House Budget Committee, Jim Chapman, who chaired the House Appropriations Committee, and Ralph Hall, who chaired the House's Science, Space, and Technology Committee. In the House, Texas had a stacked deck, and they weren't so bad in the Senate either. Republican Phil Gramm served on the Senate Budget Committee, and for the Democrats, you had Lloyd Benson.
I served with Jack Kennedy. I knew Jack Kennedy. Jack Kennedy was a friend of mine. Senator, you're no Jack Kennedy.
He had recently lost the election where he ran as VP, but he was still the chair of the powerful Senate Finance Committee. Any budgetary bills need to make it through there before they can be voted on. So, if he wanted to, say, I don't know, indefinitely prevent a bill from being voted on, he could do that. Not only that, if any testimonies were held, the committee chair gets to lead and dictate the questioning of witnesses. True Washington influence comes from committees.
Yes.
And finally, you had George Herbert Walker Bush in the White House.
But then we come to priorities. The super collider is big priority. a big part of our investment in America's future. And when you talk basic research, this is the Louvre, the pyramids, and Niagara Falls all rolled into one. And where once we reached for the moon above...
Yeah, basic in terms of fundamental particles, sure. I like that.
...to explore new frontiers of our universe, soon we'll begin to tunnel below to learn about the fundamental question of science, how our universe began.
His support for the project had less to do with him being a Texan, and more so that the SSC began under Reagan when he was VP, and it would be bad optics to change his mind now. And if you had Bush on your side, you also had his presidential veto. Sure, Congress could vote to kill the SSC, but as long as they didn't have a 2/3 majority, Bush could veto any budgetary bill as a last line of defense. Of course, Texas is just one state, and even with all their influence, they can only do so much. They needed other states on their side. Texas had won the lottery. 4,500 permanent lab jobs, 2,200 construction jobs, and $660 million in yearly lab funding. Once the site contest was over, many of the other states lost interest entirely, and with no incentives, they'd sooner vote to axe the project than vote to keep it. But just because the grand prize was claimed doesn't mean there weren't consolation prizes. Texas was going to have to rely on the great American pastime of corporate lobbying. In comes the Texas Cartel. Not a literal cartel, that was just the nickname given to the Texas National Research Laboratory Commission. It was a lobbying and management group made up of a selection of powerful local business leaders, and it had been formed by Governor Clements to help the state win the site selection contest. Among these Texas businessmen was billionaire H. Ross Perot. For some of you, that name might ring a bell. We'll be getting back to him much, much later. The cartel was quickly joined by other lobbying groups. You had ISAC, Americans for the Super Collider, and the National Superconducting Collider Coalition. All funded by Texas, yes, but operated as if they were national organizations. Why? Because their job was to convince the other 49 states who weren't getting to host a massive public works project. The main mission of the lobbying groups was to contact companies in as many states as possible and generate interest in contracts for the construction. Yeah. It's estimated that nearly 8,000 contracts...
It's going to take a lot of resources from all over the U.S. and really resources from beyond the U.S., which again goes back to the poor America First decision, because global collaboration really could have helped out and got this project going. Just make it an international project, kind of like in CERN. I mean, the Swiss didn't build that by themselves, so why should the U.S. build this by themselves?
Committed, totaling somewhere around $200 million. By one estimation, 47 of the 50 states had been awarded at least one contract. This was a tried-and-true political tactic commonly employed by the military-industrial complex, perhaps better known as pork barrel politics.
Sure.
Make sure every state has a piece of the pie, no matter how small, and it makes it hard for politicians to justify defense spending cuts. You can't slash the defense budget. If you do, steel plants in Ohio, Indiana, Michigan, Pennsylvania, all of them will have to shut down. Do you really want your vote to be responsible for thousands of layoffs? Of course, by sheer coincidence, many of the most lucrative contracts were awarded to states who had senators and congressmen who just so happened to have seats on appropriations committees, budget committees, science committees, etc. Hey, aren't you the senator from Louisiana? Say, would you and your constituents be interested in a magnet plant? Yeah. See, we need a lot of magnets, and you want jobs for your people to make some magnets. I feel like this would be a mutually beneficial arrangement. After months of the cartel greasing just the right wheels in Congress, the House and Senate agreed to allocate nearly $500 million towards construction. This budget wasn't without any speed bumps, though. A group of 3 congressmen had proposed an amendment asking to delete construction funds and allocate less than half of that for more R&D to give more time to find international partners for the project. The House voted...
I like that.
330 to 93 to begin construction on the SSC. This margin of victory was huge. Excellent news for the SSC. The SSC had officially gone from R&D blueprint to an active project. After the crushing disappointment at Fermilab, there was a clear path forward. It didn't take long for things to go off the rails.
Which is a shame, because you don't always get that much of a strong key stakeholder support when you're starting a project. Sometimes you start it with barely any support and you get more as it goes. And the problem with something like this is they're going to need tangible ongoing wins. Like, I can understand getting contracts, but as the project progresses, they're not going to see the fruits of their labors till possibly years after the thing is going to be completed, when they discover the Higgs boson, or however far they get.
Director of the SSC lab, Roy Schwitters, was faced with his first major dilemma. Who was going to replace Maury Tigner as project manager? Maury's technical knowledge of the project had been unrivaled, and the loyalty of his staff was fierce. Losing him also meant losing many of his loyal employees, resulting in a knowledge gap during the transition from California to Texas. But that wasn't the only...
Knowledge gaps are a big thing got to watch out for, especially in the nuclear industry. And that's one thing that happened with the construction of the new sites over at Vogel and Georgia, is because there's a 30-year gap in between. So previous new build in the U.S., so a lot of things were forgotten. So yeah, that's something that needs, on long-term projects like this, change of location, that absolutely needs to be on your risk register. How are you going to manage knowledge transfer?
Thing not to make the transition. One of the key elements missing from the project management was a cost and control system. These days...
Dude, then you're screwed. You need a cost and control system. That's one of the fundamentals of any project. You need some level of a design to cost framework. I mean, what are they going to do? Build now, budget later? And it needs, the project on this size is going to need its own, like, forget the political committees and all that. The project management team is going to need to have their own cost governance structure, like within the project team, not the, I'm not talking about the politics or the House or the Senate or anything like that. It needs to look at what they can approve, what their contingency funds are, because you're going to have a baseline budget, and then you're going to have a contingency budget, and you're going to need some level of ways to get that approved, because the last thing you want to do is ask Congress for more money, because one, they might not give it to you, and two, even if they do, it could take forever, which is only going to cause you to hemorrhage more cash, and it's a vicious, vicious cycle on a project of this scale.
It's practically a given that any major project in both the private and public sectors will employ a robust tracking software to keep tabs on timelines and budgets.
Or even list of approvals of cost, over even some sort of oversight framework. Man, any project at the nuclear plant, even relatively small ones, you're going to need a way to manage costs. It's not rocket science, and I'm pretty sure any big business is going to need something like that.
In the late 80s, with computer use still becoming mainstream, physicists weren't widely using them yet. On the contrary, many physicists actively resisted using such a system, as they viewed it as another layer of bureaucracy and micromanagement that was keeping them from their actual work.
Okay, but so don't do it on the computer. If that's not there, fine, but you need to have it controlled and monitored. I mean, yeah, I know this is the early days.
In hindsight, not implementing a tracking software was a disaster waiting to happen. Not to mention the contract signed with the Department of Energy legally required one to be implemented. They just didn't do it. Back in the R&D days under...
Okay, where's the accountability then?
Maury Tigner, there had been a successful system being used, but with no one to bring it over, it evaporated into thin air. Roy Schwitters needed
something that failed during project turnover.
Strong second in command, someone who could handle the day-to-day stuff while Schwitters focused on working with Washington. While searching for a permanent replacement, Doug Pewitt stepped into the role and made attempts to implement this system.
Yeah, so they're going to need, and that's pretty much a full-time thing. So the director, I'm used to seeing that as the executive sponsor role, basically the person who handles all of the politics and basically gets the purse strings loosened when need be in order to get with this project, and they would have regular check-ins with the project manager. So okay, you're going to need a really good project manager. That's arguably the most important role in the project.
but faced firm pushback from physicists who hated the system because they viewed it as micromanaging. Even senior managers like Helen Edwards kept making excuses to avoid using it. But this was a multi-billion-dollar project and would very much come back to bite them later. Eventually, Schwitters found his ideal candidate and set his sight on Richard Briggs, who had led an accelerator program at Lawrence Livermore Labs. Now, Briggs was a competent guy, but bureaucrats in the DOE, specifically Robert Hunter, saw things differently. Hunter thought that Briggs lacked the ability to manage such a large-scale project and blocked his appointment to the deputy director position. This kneecapped his authority, making it hard for Briggs to get...
So they got approval, and all this hemming and hawing on who the project manager is going to be. Man, that's like one of the very first things that happens shortly after the... I was going to say business case. I guess it's kind of the equivalent of a business case for a government project. The political mandate, if you will, for this is going to have recommendations of a project manager and said backups, but they had their guy and now they don't have a guy anymore.
Anything done. But to a certain extent, Hunter had valid concerns. The price tag for the SSC sat at around $15 billion, nearly 25 times more expensive than Fermilab's Tevatron. Hunter was insistent that the management team needed someone who had experience managing billion-dollar projects, possibly someone from a military-industrial firm. For all these reasons, Hunter made it his mission to wrestle away control from the physicists and make sure...
I mean, I get that. You can have... Ideally, you're going to want someone that kind of speaks both languages, though. Because I get it. Not a lot of scientists have experience with projects of this scale, especially since a lot of it's construction. And a lot of them just are only in the experimental and operational phase of a project. They just might not know construction. But, I mean, it's doable to have someone without a construction background, but he's going to need to basically have a advisor that's in charge of all of the construction to do all that.
That the DOE and the government as a whole had final say on many aspects of the project. The physicists eventually got fed up with this and elevated their concerns all the way up the food chain to the Secretary of Energy, where they argued that their signed contract granted them the autonomy to manage the project themselves. Lucky for them, the new secretary agreed, and Robert Hunter was pressured to resign in order to relieve some of the tension. This meant that Richard Briggs could finally be confirmed as deputy director / project manager. But Robert Hunter would later be vindicated. As the months wore on, it became clear that Briggs was less suited to being project manager than some had hoped, and Schwitters decided to let him focus solely on being deputy director and bring back Doug Pewitt to be acting project manager. If you're keeping track here, this is Doug Pewitt's second time being acting project manager. And again, Doug Pewitt would try for a second time to implement a cost management system, but reluctance from the physicists prevented it from catching on a second time.
I mean, you need a cost management system. I mean, whether it's software or whatever, if they're using old school methods, I would think it would still be easier with software, but again, I still wasn't even alive at this point in the late 80s, so I don't know how cost management was done on projects of that era. But the point is, you got to have something. I mean, when the pyramids were built, I'm sure they had a cost management structure of some sort.
To make matters worse, the two private companies that had been brought on because of their experience with military contracts were turning out to be disasters. Unmitigated disasters. In a memo from one of the SSC board members, EG&G and Sverdrup were flooding the place with people, most of them incompetent or poorly suited to the tasks they were being assigned. Sverdrup was supposed to be handling construction, but according to some of the physicists, they'd been sending their third-rate employees to Texas, who would otherwise have been laid off. In fact, Sverdrup seems to have outright lied about their company's qualifications. They had been brought on to dig the tunnels for the project because they had worked on the Baltimore Harbor Tunnel. Except, it seemed like they had zero experience digging tunnels. I don't know how that happens. The company as a whole was so incompetent that their executive...
Did they contract it out or something?
Robert Bobbins, who had been named director of conventional construction, was forced to resign within months. His replacement, Lew Smith, was also forced to step down soon after. The SSC management opted to outright terminate the contract of Sverdrup, leaving a handful of physicists to have to step in and manage the construction themselves until they could find a new company to take.
That's challenging. Yeah. Not saying physicists aren't capable and they could eventually learn it, but trying to do something that is essentially not your job and you not necessarily have much of a background in construction, it's just a different game. It'd be like asking me to design clothing or something. It's like, no, could probably figure it out eventually, but it's just not what my background is.
Over. The other company, EG&G, was in charge of general administration and technical support. They weren't nearly as incompetent as SfaredUp, but due to scheduling delays, their employees had very little to do except twiddle their thumbs and collect a paycheck. It's said that EG&G also tried to implement a cost and control system, but this
And there's always people that kind of exploit that inefficiency when you have these massive fall-offs and projects delays. There are some times when you're delayed in, say, a refueling outage in a nuclear power plant, and you have something holding up fuel movement. You're essentially paying fuel mover contractors to sit in their hotel rooms and get paid because you've run into some delay that requires that the critical path of the project is all dependent on this one very specific crane crew or one specific maintenance crew to say replace a residual heat removal pump that is preventing the rest of core refueling to continue. So you can have these bottlenecks that are forcing a lot of these contractors to sit and essentially get paid because any minute now they can be called back in to go back to work. So you want to continue to have them there, continue to have them briefed. I mean, they're not completely doing nothing. They're at least keeping up with what's going on and being briefed on what their tasks are to know that when they come in, it's go time. But it's a lot of wheels spinning without going anywhere.
Also failed. Worst of all, though, the long delays led to yet another departure from the management team. Bruce Chrisman had been assigned to handle administration, but he had opted to return home to Fermilab, leaving many unfinished tasks in limbo. For those keeping score at home, it is May 1989,
a lot of red X's
and all
on this
but
thing.
2 of the original managers have either resigned or been forced off the project. That left Roy Schwitters as director and Helen Edwards as head of accelerators. Now,
Those
fortunately,
two
Helen
original
was
of the
an ideal
simulation
pick
team.
for her role.
Wow.
She had been one of the lead designers of Fermilab's Tevatron, but she had the unenviable task of adapting the design plan first drafted by Maury Tigner before he left the project. Tigner's plan had been purposefully generic, as the Texas site hadn't yet been chosen.
Sure.
It was Edwards' job to adapt it
Define
to Texas.
everything.
But during this process, she had come to the realization that a lot of changes were going to have to be made. Tigner had chosen a risky design. He wanted magnets with an aperture size of 4 centimeters. This is risky because magnets have a sweet spot of sorts, kind of like a tennis racket. The bigger the racket, the bigger the sweet spot for hitting the ball. The magnetic field is the most uniform in the
I
direction
mean, sure, yeah. It has to do with strength and the various, magnetic field profiles you have when arranging your magnets.
center and quickly deforms near the edges. A larger magnet aperture of 5 centimeters would fix this, so it'd have a larger sweet spot. But it would be more expensive to manufacture because it's bigger. And also, the diameter of the total collider would have to be extended by a few
That's going to
kilometers.
scale up.
She simply viewed the 4 centimeter magnets as too risky. If Tigner were still with the project, maybe he could have pulled it off. It was his design after all. But this was Edwards' job now, and she wasn't confident that she and her team could pull it off, so she wanted to go with a safer, more conservative, but also more expensive option. Ultimately, Roy Schwitters listened to Helen Edwards, and he was on board with the magnet change.
Okay.
So now it was up to him to convince.
So it's basically, the trade-off here, it's a bit of a gamble, but you're going to have to spend more money up front. That's going to make the thing more reliable in the future. I mean, sure, you want it done right. You don't want to have to go back and replace this thing.
It's the bigwigs in the Department of Energy that they needed $4 billion more. Just sweep it, just a little bit. But since Reagan left office, Bush had appointed an entirely new team of bureaucrats to head up the department. And the new Secretary of Energy had some strong opinions on how the SSC was going to be managed from here on out.
Waste not, want not, probably.
On November 9th of 1989, 2 very important things happened. Number 1, the Berlin Wall came down. Number 2, Roy Schwitters visited Washington to deliver some very bad news to the new Secretary of Energy, a man who wasn't exactly in the mood for bad news because of the first thing. A couple years earlier, both the US and USSR had agreed to scale back their nuclear arsenals, but the fall of the Berlin Wall marked a clear turning point in the Cold War. It was basically over. And now the American public had to reckon with the consequences of the insane nuclear buildup of the past decade. Turns out when you test thousands of nuclear warheads, you generate tons of nuclear waste. The 80s had...
You do, and a lot of fallout, depending on the altitude of detonation. So you're either going to have fallout that's going to go airborne and get dispersed. So low dose, but it's going to, and I say low dose, I mean relatively low dose, but it's going to go everywhere, or concentrated dose if you're talking about a surface detonation or even a subsurface detonation, but it's going to contaminate everything in the immediate area. So, and they did all three types of testing over these few decades during the Cold War. So they have a little bit of everything to worry about. And the nuclear waste, there's also nuclear waste that's produced during the manufacturing of said nuclear weapons. Forget actually detonating the things. So yeah, it's a lot to manage, which is a shame because a lot of it could be used, not the highly enriched stuff that used to actually make the weapons, but a lot of the uranium could have been used to just make fuel for more power plants and develop a more robust integrated waste management system. But a lot of this during Cold War stuff, waste wasn't managed as effectively as it was now.
Given rise to a vocal anti-nuclear weapons movement, and thanks to the Chernobyl disaster, it had gradually morphed into an anti-nuclear anything movement as well. Remember, part of the reason Fermilab lost out on the Super Collider was the vocal anti-nuclear movement. Now, of course, the Super Collider has nothing to do with nuclear waste, but because it was the same department, its budget and public perception were also going to suffer. There was immense pressure for the DOE to clean up.
If the same department sold chicken wings or something, people would say the chicken wings are radioactive.
The mess they had made, a process that would end up costing billions of dollars. A 1996 estimate pegged the total cleanup cost at $646 billion. To put it in perspective, a single year's worth of nuclear weapons cleanup was going to cost more than the entire estimated cost of the collider.
Wow.
To tackle this crisis, President Bush needed to appoint a new Secretary of Energy to spearhead the cleanup effort. Hence, Admiral James D. Watkins. Yeah, remember him?
And the reason why that's so expensive, all that waste, because all the different types of nuclear weapons testing, the manufacturing of nuclear weapons, it can stack pretty badly. Plus, the reckless abandon for a lot of how those things were tested.
Chair of the AIDS Commission? And you thought I was just soapboxing. Well, yeah, I was, but it's all connected. It seems like whenever Reagan and Bush had a tough problem they didn't really care too much about, they called in Admiral Watkins. Thankfully, compared to his last White House job, Watkins was slightly more qualified for this one. Trained as a mechanical engineer, Watkins had served most of his career in the Navy and even commanded a nuclear submarine. For this reason, he had...
A lot of people in nuclear power plants, we hired a lot of naval mechanics. A lot of them become reactor operators even.
An immense respect for the technical wizardry of nuclear physicists and was generally in favor of the SSC and its mission. Not to mention it was a priority of President Bush. Watkins was a military man at heart, and he planned to bring discipline and order to a project that he saw spinning wildly out of control thanks to the mismanagement of long-haired academics. He was deeply afraid that if costs kept ballooning as they were, Congress was guaranteed to axe the project. During his 4 years as Secretary of Energy, Watkins would be one of the SSC's fiercest allies and defenders. But at the same time, his militaristic management style would only exacerbate tensions between the physicists and the DOE, and he would make several key moves that would directly undermine the power of the physicists in charge of the SSC. Anyway, back to that fateful November day. Roy Schwitters had finally agreed to the magnet changes requested by Helen Edwards. Schwitters then informed Henson Moore, the second in command to Watkins, that the SSC would likely require a budget increase. Apparently, Moore's response was, either we're going to build it for the figure we agreed on, or we're not going to build it at all. When Admiral Watkins learned of the required cost increases, he apparently, to use an expression I'm just now hearing for the first time, he became non-linear. God, I love that. And reportedly had to be scraped off the ceiling. Schwitters stated that the next time he met with Watkins, he was screamed and sweared at. The SSC management...
I'm going to have to use that the next time I get into an argument with someone. Suddenly they became non-linear.
And the DOE had enjoyed a brief truce where things had been going smoothly, but tensions had once again rocketed up. 30 TeV?
I mean, that's less than the Large Hadron Collider at this point. I mean, that's still more than the Large Hadron Collider.
Or lower? Yeah, that...
Wow. Magnet missiles. I mean, magnets can become missiles if you repel them too hard.
This toxic work with his boy.
This whole thing is one thing that does come up within the commercial nuclear industry a fair bit. There's often a fair number, usually it's middle managers that were ex-Navy. I myself was not. And sometimes there's a little bit that's reflected in how the leadership style is. And there could be some differences of opinion that could often lead to people deferring just out of rank, if you will, by someone being a more senior manager. And I even, as part of my technical training, I needed to learn command and control style leadership when I became a control room supervisor, for instance, which was different. I mean, I figured it out, but it was something that just hasn't come up with me before when I was in the engineering division and then moved on to the operations division. So differing things, I wouldn't say it's something that is insurmountable, but you just need to navigate a project or a company's leadership style. But all these changes in management and having to get people pivot so much while you're still working on a project, that is going to turn some people off, lead to some resignations, lead to delays, and lead to costs going up if you keep revolving this door too much. And not just revolving the door, revolving the company culture, I guess the project culture in this sense.
Siskin slotting into the newly created role of general manager. On paper, this meant a reporting structure of Reardon under Siskin and Siskin under Schwitters. On the one hand, Siskin's appointment would bring in much-needed management to the project. On the other hand, many physicists suspected that this was a covert attempt to add in additional layers of bureaucracy to wrestle away control from Schwitters by bypassing him entirely. Watkins may have respected physicists for their technical knowledge, but that didn't mean he trusted them with a billion-dollar project. In early 1990, Congress passed a bill that granted Watkins further control of the project, and created the Office of the SSC, a management group entirely within the DOE. Watkins then dipped into his Navy contacts yet again and recruited Joseph Cipriano to be project manager of this new office. Watkins told him that he calculated a 50% chance that the project would be killed if costs didn't come down. Cipriano's mission was to clamp down on those costs, and Watkins basically gave him equal power to Director Schwitters. In particular, Cipriano completely took over the contracts for tunneling and construction, which in
the org chart is becoming more diagonalized.
Enraged Schwitters and his management team. So with just a few rapid appointments of his friends, Admiral Watkins had erected a parallel management structure, all of whom could report directly to him. He had found a way to entirely bypass the physicists, and there was almost nothing they could do to stop him. Besides these three critical appointments, there was an emerging culture clash between the physicists and engineers from the military-industrial complex. As a rule of thumb, physicists like having the choice to swap out components or materials at the very last minute to maximize performance. But engineers are used to following strict timelines, locking in parts very early on to guarantee low cost and low risk. And thanks to the Admiral's appointees, they made sure that when it came down to it, the engineers...
And I mean, look, that's the school of project management that I went to, so I get it.
Get the final say. Jamming a bunch of physicists and engineers onto the same project without a pre-existing working relationship was always going to lead to some friction. But I don't think anyone expected it to be this much friction. At the risk of beating a dead horse...
you're making parallel departments, that is a mess.
Of course here, if the project had instead gone to Fermilab, there would already have been an established staff of physicists and engineers who worked well together, and you wouldn't have the same friction. But again, if ifs and buts were candy and nuts, we'd all have a Merry Christmas. As the military contractors gradually took hold of more and more of the project,
and we'd find out the Higgs boson in 1997.
Experienced physicists felt they were being micromanaged. Think back to the three main pillars of the project. You had the tunnel, the magnets, and the detector. The tunnels and magnets were now firmly in the grasp of the military-industrial complex, and the physicists were clinging to the detector as the last bit of agency they had on the project.
That's a mess.
This meant two things. Many senior physicists were fed...
I mean, they all got to work hand in hand. You're going to have detectors that aren't going to be combustible.
And every single original manager, except for Schwitters, has either resigned or been forced off the project. It was hard to argue that Admiral Watkins wasn't effective. He had slowly reined in a project that was quickly spiraling, but the collateral damage of a toxic work culture might have doomed the project in unforeseen ways. Now, it's important to keep in mind that while all of this was going on, the SSC has not been lurking out of the public eye. It did not enjoy the relative lack of oversight that previous accelerators had. All while it was undergoing management upheaval, resignations, and internal squabbling, the SSC had been enduring a three-pronged attack. Vicious criticism that questioned whether the project should continue to exist.
Red, white, and blue.
Prong 1. The media. In the early days of the SSC, the media had reported on it favorably as a way for Americans to show the Europeans who was boss. In one article, the New York Times stated that American accelerators should be designed to win or not be built at all. The 3-0 loss in the boson race cries out for earnest revenge. But by the 90s, the American media was singing a very different tune. The average journalist lacked the scientific knowledge to write about the goals and capabilities of the project, and therefore wrote about the parts they did understand. The ballooning cost and growing mismanagement. So it should come as no surprise that the average American perceived the project as an ever-expanding money pit, and not the next step forward when it came to understanding the universe. Even science-focused media wasn't especially kind to the project. The influential American journal Science ran a couple dozen articles on the SSC in a 5-year period between 1983 and 1988. Of those couple dozen, only 5 focused on the technical aspects. All the others covered the rapidly growing cost of the project. The SSC had cultivated a perception not as a science project, but as a public works project, and one that mainly benefited Texas at that. And although your first instinct might be to decry the so-called lazy journalists, can you really blame them? Particle physics is supremely abstract, full of weird names and terms.
It's hard to communicate this to people and to give tangible wins along these steps of the project to keep average people invested in it. At least with building nuclear power plants, you're going to say, okay, it's going to make more electricity for us. This, you can't, the tangible benefits are going to be largely unknown at this point to the average person. I mean, yeah, you could talk about this, fancy square being filled in and Higgs bosons and America being the center of particle physics, and you could even see breakthroughs in superconducting technology within power grids, medical imaging, maybe even within nuclear fusion containment. But a lot of that is more branch off stuff, things that you could do to potentially apply this physics with an unknown release date of things to look forward to. So, no, I don't blame these journalists.
And is generally just very confusing. Look, I'm the one narrating this, and I don't fully understand it. It's not my thing. I think you could make the case that this was partially a failing of the particle physics community. For many decades, particle physics had enjoyed the unwavering support of the US government and had not been subject to much public scrutiny. But now, with their giga machine being paid for by taxpayers, it was their job, their responsibility, to convince the public that the cost was worth it.
This isn't we're going to smash particles to beat the commies either, because that part's done at this point.
There was a pervasive attitude among particle physicists that they shouldn't have to pander to Joe Schmo. They should just be allowed to get on with their work. A real, you reap what you sow kind of situation. There were exceptions to this, of course. Steve Weinberg wrote a great book on the SSC, for instance.
I don't think it's true that elementary particle physicists have claimed that their branch of science is more important than other branches of science. And I'm reaching an age at which I'm beginning to think that research on the prostate is more important than anything else.
But the MVP was still Leon Lederman. He was an immensely talented educator who gave dozens of speeches and wrote books trying to explain just what was so important about the goddamn Higgs boson. It was him who popularized the term the God particle. But this effort to educate...
In case you're wondering, the goddamn particle is a particle that's been accelerating quite fast.
Educate the public was too little too late. And 18 billion, or however high it was going to go, was too steep a price. Contrast this with NASA. NASA's budget reached an all-time peak during the space race, accounting for 4% of the annual US budget in 1966. The Apollo program spent nearly $257 billion in just over a decade. And even as budgets dwindled during the 80s, 90s, and 2000s, humans were still being sent into space, albeit with some help from foreign partners. NASA has always had two key things in its favor: the enthusiasm of the public and a concrete mission statement. NASA spends millions of its budget on outreach programs to engage directly with the public education system, teaching kids from a young age about planets, asteroids, satellites, and the like. Ask any 8-year-old to name the planets, and they probably can. Ask the average adult to name a single lepton, you probably can't.
Yeah.
So when NASA says we're going to land on the moon, or we're sending a rover to Mars, every American knows exactly what that means and why that's cool as hell. And even though a moon landing doesn't have much in the way of real-world applications, we recognize that along the way, we've learned how to launch satellites, telescopes, and more.
All the
Particle physics doesn't
technologies.
have that. The fact of the matter is, you can televise a moon landing. You can't televise the Higgs boson. And that leads us to...
Well, you can, but people aren't going to see
other
much.
scientists. Simply put, there was an ongoing civil war between big science and small science. Big science meant billion-dollar giga-projects like the SSC, the space station, and sequencing the human genome. Big ideas that were meant to showcase American competitiveness, but with no clear short-term payoffs. Small science, on the other hand, was everything else. The niche, unexciting research that is, nonetheless, the backbone of innovation and progress. Unfortunately, small science was often critically underfunded or not funded at all, and thus an army of academic critics rallied their forces and got to work attacking the SSC.
Mr. President, how about experts in the private sector? What is their view of the SSC program? And here is how they ranked them. Number 1 was the Human Genome Project. Number 2 was the National Aerospace Plane. Number 3 was the space station. Number 4 was the Strategic Defense Initiative.
Oh wow, Star Wars.
Number five, the superconducting super collider. In other words, Mr. President, America's corporate scientists rated the SSC dead last in terms of its benefits for our national competitiveness.
And these critics weren't no-names either. Many of these people represented the condensed matter community. Nobel Prize winner Philip Anderson led the charge on this. The 1980s were a major period of change for superconductivity, and it seemed like every month a new material was found that supported superconductivity at warmer and warmer temperatures. The argument was that high-temp superconducting magnets would be much stronger and could operate without the need for helium coolers, which in the long run could reduce the ring diameter by a factor of 5, potentially saving billions of dollars. They were basically demanding that the SSC project be put on hold for a few years to study the new materials.
I mean, and there's a legitimate criticism to that, because again, would you want to build something really big when your technology stack, the magnets, might not be the best magnets for the job? It's the equivalent of, do we try to send a spacecraft to Alpha Centauri now, a generation ship that takes 20, 30,000 years to get there, and by the time they get there, they're going to find it already colonized by a ship that got there faster. Essentially amount to a waste. And that's why we haven't done that for long-range space probes, because, we're probably going to get better propulsion technology by the time we would send something like that there with current technology.
2 separate academic panels investigated the topic, but ultimately found that it could delay things by anywhere from 4 to 8 years. A delay this long could ultimately kill the project, and thus it was decided to move forward with the current magnets. In retrospect, I should note that to this day, no such breakthrough in room temperature superconductors has occurred. And just a few years later, Philip Anderson had gone from wanting to delay the project...
And one thing about trying to do something on this scale, you're going to get technological maturity that you could eventually use other superconducting applications, such as fusion.
...to calling for its outright cancellation. He was joined by a few other big names. Big science has gone berserk. The American Physical Society, an influential organization within the field, was forced to edit its official position on the SSC, otherwise the condensed matter community was threatening to leave. And thus the APS made the delicate change from "we endorse the SSC" to "we endorse the SSC if it gets finished on time without hurting the funding of other subfields."
Wow.
As part of its marketing campaign, SSC proponents had made a big deal about the many potential spin-off technologies that could arise from any discoveries. They touted concepts such as better MRI tech or high-speed maglev trains. This was widely seen as a slimy tactic, as particle physics was, at best, tangentially related to these offshoots.
Yeah.
Doctors who today announced that protons from the giant atom smasher will be used in medical treatment.
The time of the gentleman has expired.
My friends, this site will use the protons from the super collider to cure cancer.
Yeah. All we got to do is put you in the super collider, in a vacuum, of course, and we're going to go ahead and bombard you. And yeah, you're definitely not going to have cancer anymore, I can tell you that much.
This is the future of America. This is the project we ought to support. Vote down this amendment.
Gentlemen's time has expired several times.
Everyone agreed that the SSC would be excellent for physics. Wisconsin's Dan Obey. All high-ranking members of their respective state delegations who had seen their hometowns suffer economically for the past decade. The most recent addition to the team was Kansas Democrat Jim Slattery.
Mr. Speaker, when we talk about this question today on the Super Collider, those of us who are opposing the Super Collider aren't doing so because we're against scientific research. And let me point out that the chairman of the Science, Space, and Technology Committee in 1992 also said, and I quote, "To fund this project would require massive reductions in other critical science programs, including other high-energy physics programs. Keep that in mind, my friends."
But none of them were comparable to the absolute terror that was New York Republican Sherwood L. Boehlert. Say what you will about his politics, but I've watched more than enough C-SPAN to tell you that he is a phenomenal public speaker and a brutally efficient interrogator. And if you happen to be sitting across from him during a committee questioning, you better pray for your life.
We are hearing, as we have just heard, some claims made for this project. Contrary to all the hype, the SSC will not cure cancer.
They'll have their powerful ally in Senator Bennett Johnson, and thanks to him, the bill emerged from committee with an additional $150 million.
I mean, it's both good, but it's also just the sunk cost. This is just going to add to the whole sunk cost when you realize this just isn't going to work.
Lopped back on. The SSC budget survived the Senate vote 62-37. But still, it was hard not to worry about future votes. As a side note, whenever the House and Senate disagree on an exact budget number, a hybrid committee consisting of both House and Senate members ends up getting formed, and they hash out the final number. In this case, the disagreement was small, and thus a compromise figure just shy of $1 billion was reached. This would be the last time such an easy compromise would be made. From this point on, the House and the Senate would only become further at odds. Anyway, the Soviet Union collapsed. Not all at once, mind you. A few economic reforms over here, a wall getting torn down over there, a saucy little attempted military coup, you know, one of those. And wham bam, thank you ma'am, now you've got yourself 15 new independent nations, an economically drowning Russia, and a big hole where there used to be a big bad villain. TM. In the blink of an eye, the US government had lost its major justification for why it was spending so much money on its military, and by extension, overly ambitious Cold War era science projects like the SSC. With the Soviets gone, who were we trying to beat? Not to mention, America was deep into another recession. Due to deregulation that began under Carter and continued under Reagan, a real estate bubble backed up by fraud led to over 1,000 savings and loans companies folding. Funnily enough, Texas was home to nearly half of these. At the time, it was the largest economic crash since the Great Depression. This was only worsened by losing trade wars with Europe and Japan, which undercut American manufacturing. Finally, the country was still stuck with the tedious cleanup of nuclear waste generated from a decade of Reagan and Bush's defense policies, a process that was soaking up a large portion of the DOE budget. For the first time since the end of the Vietnam War, Bush was finally scaling back the defense budget to a sizable degree. And the hope of many was that the decreases in the military budget could be used to fund other programs. These were the so-called peace dividends. Ideally, this funding would be diverted from war to address literally any other
anything else,
healthcare, education, jobs. So what do you think happened? Text the number on screen with your answer. As part of its deficit reduction policies, Congress erected a firewall between military and civil spending. A decrease in one couldn't be used to fund an increase in the other. Congress had crushed the hopes for a peace dividend. Funny how it always works out like that. Now, for Bush, as former head of the CIA and his Secretary of Defense Dick Cheney, these military budget cuts were like pulling teeth. And for all the aforementioned reasons, his polling numbers weren't doing too great either.
Yeah, he didn't do good.
If only there was something he could do to kill two birds with one stone. With the Soviet Union actively disintegrating, the US needed new supervillains to focus its
new supervillains, not the Super Collider.
Desire, and thus began a pair of extremely short, hot conflicts that were used as a showcase for all the fancy high-tech death toys that had been originally intended
So
for
the
the
Gulf War.
Soviets.
Okay.
What started off as Desert Shield inevitably morphed into Desert Storm. Basically, Saddam invades Kuwait over what is supposedly oil field disputes, and Bush assembled a UN coalition to kick him out with a side of relentlessly bombing Iraq's infrastructure and sanctions that drove the country to a state of starvation. And don't mistake this for the Simping for Saddam power hour. It's just a little questionable that George here had such a change of heart after spending the last decade lending Saddam money, illegally selling him rockets, aircraft, and chemical weapons supplies, defending his human rights abuses, and silently cheering him on when he was invading Iran. Following Desert Storm, Bush's polling numbers shot up to a peak of 89%, a level that made Democrats wonder if it was even worth running a candidate in '92. And it helped to cement US influence in a region of the world that was previously off limits due to the long shadow cast by the USSR. Next one.
Please?
Oh my god. Are you for real? Finally though, for reals this time,
angry
Bush
face.
and Kai-Fu publicly announced the SSC would be a topic at their next summit
Talk about your
in
poor
November
stakeholder management.
1991. Bush even sent a letter to formalize things. Finally, after months of dancing around the issue, some actual progress was going to happen. So anyway, Prime Minister Kai-Fu was forced to resign by a coalition of three powerful factions within the Liberal Democrats. Kai-Fu had belonged to the weakest faction of his party and only rose to prominence because he was a Mr. Clean candidate, untarnished by recent scandals plaguing the actual top players. He was replaced by Prime Minister Miyazawa, a politician who was much less sympathetic to scientific interests. His past political appointments included Minister of Finance, Director of Economic Planning, and International Trade and Industry. In other words, someone who was going to play hardball when it came to money. But regardless of whoever Japan's top dog was, the US was not in a position to be making any demands. For one, the US had already asked for help in the Gulf War. Japan had dragged its feet regarding the war and was heavily criticized. Not wanting to get involved in actual combat, Japan offered purely monetary aid in the form of a few $billions. But the true issues were decades in the making. Classic case of reaping what you sow. The US had pumped billions of dollars into Japan post-World War II to make it a dominant East Asian capitalist utopia in a region of the world surrounded by communist states. But now, 30 years later, Japan was an economic and manufacturing powerhouse, completely kneecapping major American industries such as steel and automobile parts. And while America may have invented the silicon transistor, Japan was making it their own. In 1975, America had 100% of the semiconductor market under their control. By 1986, that share was down to 5%. Most of that share had been lost to Japan. Hence why the government was so eager to fund Semitech, that other Texas gigaproject I mentioned earlier. In the eyes of some American politicians, Japan wasn't just a country. It was Japan Inc., a coordinated juggernaut of a government and the private sector. With the previous November 1991 summit pushed back to January, Bush had a choice to make. Fight a trade war over automobile imports in the middle of a recession, or politely ask for a couple $1 billion for a deeply mismanaged particle accelerator.
Wow.
Can you guess which one he chose? Well, he didn't really get to make a choice. Bush chucked it up. Like during dinner, he fainted and then vomited directly on the lap of the Japanese Prime Minister.
Wow. You can't make this up.
The incident quickly became a running joke on late night TV. In Japan, the slang term was coined, literally translating to do the Bush thing. The approximate cause of the incident was a combination of two factors: improper medication amounts, as well as exhaustion from a long journey. The incident preemptively ended the dinner and cut short any chance for a one-on-one conversation about the SSC. Now, obviously, George Bush vomiting didn't literally ruin negotiations, although it's extremely funny to think that it did. In reality, diplomats from both countries kept trying to make things happen behind the scenes, but Japan refused to budge unless Bush explicitly asked the Prime Minister face to face. Bush had 5 chances to do so, and he never did. Asking about the SSC would have put him at a disadvantage during trade negotiations, and Bush wasn't willing to take that risk. So for that reason, and because Bush faced an increasingly dire chance of re-election, the Japanese never made a commitment to the SSC. The United States would continue to take a leap into the unknown, alone.
Swords drawn.
As 1992 progressed, things seemed to settle down for the SSC. In fact, some things were actually going right. The work culture at the Texas site was finally seeing some successes. John Rees had just been appointed project manager, the sixth and final person to fill that role, ending a 5-year-long revolving door that had plagued the position ever since Maury Tigner first left it vacant. The previous project manager, Paul Reardon, had spent months butting heads with Edward Siskin in what some people described as having swords drawn. Thankfully, Rees and Siskin were able to get along, ending what can only be described as a complete boondoggle. And Siskin had finally managed to institute a cost-tracking software. Can we get a hell yeah in the chat? And there were even a few victories on the technical front. One building was finished, with another set to be built, and the contract had finally been awarded for the tunneling. The hope was that it would commence in fall of 1992. And if this last one doesn't make you sigh with relief, I don't know what will. They'd gotten the magnets to work.
The missiles.
Mass production would soon follow. Clear roads ahead. It was this renewed sense of hope that carried them into the budget cycle of 1992. June 17th. Ohio Democrat Dennis Eckhart introduces an amendment to the House's energy and water bill for fiscal 1993. It was yet another amendment to kill the SSC. Here's $67 million, shut everything down, go home, you're done. Remember that just last year, this same Congress had voted on a similar amendment, and it had failed, with 251 voting to keep the SSC and 165 to kill it, a margin of 86 votes. Odds were the vote count would be similar, but with a slimmer margin. And so, the votes rolled in.
Here we go.
232, 181.
Wow.
Okay, not the worst. Again, the margin was slowly disappearing, but it was still a win for the SSC. That's what I would say, except the totals were swapped. Hopefully, you feel just as dumbfounded as the SSC supporters did. Concerns of their local constituents, and thus might be inclined to cut projects that don't help their districts. Whereas senators have the benefit of being able to take less popular votes that consider the long term. And it was the general attitude in the Senate that the SSC, despite its price tag, was a solid, long-term investment in American productivity. That being said, it wouldn't be an easy fight. The SSC still had Bennett Johnson on their side, but for the first time, the SSC had a vocal critic in the Senate, a little old Arkansas Democrat, good old Dale Bumpers,
good old boy,
who is ready to throw down the gloves.
Now here, there is one physicist in the country that will tell you that he knows that the Higgs boson exists, and that after we spend probably $20 billion erecting this monstrosity, that we're going to find it.
Half the gross national product of today's America is made up of discoveries of the last 30 years, half of it. And we can make this, we can say, as Senator Bumper says, these secrets of science will be there 50 years from now or 100 years from now. Well, frankly, they won't. They would have been discovered by somebody else, and the technology developed by somebody else. We don't do it.
Johnson managed to finesse the SSC's budget through committee, resurrecting it from zero up to just over $1 billion. When Bumpers threatened an amendment to kill the SSC, several appeals were made to President Bush to make a show of support. Because Bush was facing a difficult election race, securing the state of Texas was even more crucial, and thus he met with 5 Republican senators to convince them to change their votes. And so, after hours of testimony and debate on the Senate floor, the votes came in. 62 to save, 32 to cancel. They saved it. Not just saved it, the margin in the Senate had actually grown by 5 votes. Except they weren't Clinton would very likely still have won the election even without Perot taking votes from Bush. But it's fair to say that Bush had a much tougher campaign. Ironically though, by helping to unseat George Bush, Perot had put the SSC, a job creation machine, in a tough spot. The SSC had not been one of Bush's priorities, but he also couldn't terminate the SSC because it would retroactively make Reagan and himself look bad. So he made it clear he'd use his presidential veto if it came down to that. And Clinton, although not an enemy of the SSC, had made no such promise to use his veto power.
Not exactly an ally.
Bill Clinton wasn't the only new face in Washington. Joining him was a record number of freshman House reps and senators. In fact, it was the largest number of freshman members of Congress since the post-Watergate midterm elections. And regardless of whether they were Republican or Democrat, they shared one key thing in common. They were deficit hawks. They ran on promises to slash the bloated federal deficit in any way they could. And lucky for them, there was one pretty obvious project that was almost screaming to be cut.
Yeah.
And there was no more presidential veto standing in their way.
We're going to go ahead and call it a part there. Man, I'm loving this. Please stay tuned for part 3. I'll see you next time.